This is the second video for E.2, work continued in gravitational potential energy. In this video, we're going to talk about, well, gravitational potential energy. We're actually going to derive an equation which shows where this term comes from, look at the basic definition, and then see its relationship to work. All right, so let's get right to it. Let's look at the work done by the force of gravity as a ball falls downward. So I have a ball located right here, okay? It's falling down because, of course, we're on Earth, and when you let go of things or you throw something up or down, it's going to fall downward. So let's just say it's starting 5 meters up, and we're going to look at these two moments from when it's right here to when it's right here, from 5 meters up to 2 meters up. All right? Well, if we're looking at the work being done, that's based on the force that's acting parallel and the distance the object travels. In particular, we're looking at the work done by gravity. So we want to use the force, which is weight. We got a little bit of a confusion. We have two W's here. Don't get confused. This is work. This is weight. We'll get rid of it in just a second. Times d. Now, of course, we know that weight acts straight down and the ball's falling straight down. So we don't need any sines or cosines or anything. That's going to equal m times g multiplied by d, the distance the ball falls. Now, in this case, you could tell me pretty easily the ball is falling 3 meters from here to here. But I want to make a general equation. The ball starts at h0 and it falls to a spot h. It traveled, in this example, 5 minus 2, but more generally it traveled h0 minus h. Well, last thing, the work done by gravity, if I just distribute mgh0 minus mgh. Voila! There's my expression. The work done by gravity is based on the mass, gravity of course, and the difference in height. And once again, just like when we saw it with kinetic energy, we have two very similar things, two terms in mgh, and there's a change going on. Well, that's where the idea of gravitational potential energy really comes from. When the force of gravity does work, it causes something to change, and we call this change gravitational potential energy. And the work being done is that change. So, the basics. Gravitational potential energy, if you abbreviate it, you might see GPE, gravitational potential energy, but it has a mathematical symbol, and that's U with a subscript G. U represents potential energies. There's actually several. We're going to look at another one later on. Potential energy. I don't know why they use the letter U, but they do. G, because it's this specific type, gravitational potential energy. Think of it as the potential to fall. This ball here can fall off this cliff. Okay, it has the ability to do something. It could fall. If there's someone down here, maybe it bops them on the top of the head. That's doing something. All right. It's based on the object's mass and height. And here it is. There's that single term. All right. Mass times g times h. Now, the second bullet point here is important. Gravitational potential energy is all about looking at some reference point. It's really all about looking at a change in height. And here's what I mean. This picture is okay, but I'm actually going to redraw the ball right here, right on the ledge. Well, this ball, relative to the ground below, has some gravitational potential energy because the ball could fall some height. But does the ball have any gravitational potential energy relative to the cliff itself? Not really. The ball can't fall onto the cliff. It's already there. Maybe if you're sitting at your desk, think of something that's on the desk. I have a calculator right on my desk. Well, the calculator isn't going to fall on the desk. It's already there, but it could fall off the desk and onto the floor. If you're on, let's say, the second floor of a building, okay, maybe it's a house, maybe it's an apartment, maybe it's a business, you have gravitational potential relative to the ground below, but not relative to the floor, or at least it would be equal to 0. So gravitational potential energy is really all about some difference, okay, some change in height. So while this is a simple equation, it's pretty straightforward, this is what the AP equation sheet gives you, AP equation sheet. And I just don't want you to be confused. They are simply highlighting the fact that we really care about the change. Okay, the ball going from here to here. All right, that's what's important. It's really all about a change in y, a change in height. Okay, but you could write this. You'll see me write this quite a bit. This is commonly written in textbooks. All right, but the AP test, their equation sheet is highlighting the fact that it's all about the change. The last thing I want to show you, then we'll be all done, is what's going on, the link between gravitational potential and work. And there must be a link. That's how we actually derived it. I have kind of the opposite going on right here, where the ball is moving upwards. Imagine tossing a ball into the air. Well, as the ball's going upwards, it's gaining gravitational potential energy. Because remember, UG is mgh. It's gaining height. If it's gaining height, it's gaining gravitational potential energy. But the work being done is negative. And if you're not sure why, remember, work is force parallel times distance, and it's negative when force and distance are opposites. If the ball's going upwards, the distance is this way, but the force due to gravity is that way, so it's negative. And the opposite's true. If the ball is falling downward, it's losing GPE. But in this case, when it's falling down, we already did this. That's the first thing we did. The force is down and the distance is down. It's positive. So we have this link here. They are opposites. When UG goes up, the work becomes negative, or the work is negative. Okay, when the work done by gravity is positive, that means the gravitational potential energy is going down. This will be an important link in the future, okay, this relationship. All right, thanks for watching.